Well, welcome everyone to day 2. I have to say day 1 was fantastic, but I look at the agenda, I think day 2 is going to be even better, right? As long as we can fly out on Friday or Saturday, that's all I'm worried about. But again, welcome, day 2. Our openBIM Roads and Bridges Transportation Summit. We are going to say thank you again. This has been a really great event to partner with BIM Week. So I hope this has worked out for you. You've learned some things and we've been able to come together. So again, thank you to Stan, which isn't just me. Somebody called me that today. But we have a whole bunch of us doing this. And then thank you to the BIM for Bridges Pooled Fund, BIM for Infrastructure, and thank you again to AASHTO and Building Smart, especially for having this. And then our sponsors, I keep saying the coffee, go get coffee. We also have our platinum sponsors. We couldn't do it without you. So thank you to Autodesk, LeapThought, and Esri. And we're going to hear from them today.
Yes.
Yeah.
All right. So yeah, we're really excited about the agenda today. And today it's all about how are these tools being applied. We call that openBIM in action. We've actually got a variety. I think there's 6 different projects that we're going to talk about today. How we're using openBIM, what's going well, what's not, and from many different angles. The bridge pilots from a construction angle. So really looking forward to that. We've also got a technology provider openBIM demonstration. We took the pilot, the IFC files from our bridge pilot projects, and we gave it to many technology providers, and they're going to show how they can leverage that data in their software for construction use. So I'm really looking forward to that. After that, we'll do lunch. And then in the afternoon, we continue the openBIM in action, getting a debrief from iHeap for those of you that weren't able to attend. Tom Hamski is going to give us a debrief of what happened there, talk about some of the ADCMS efforts with Caltrans and WashDOT, and also get updates from AASHTO, where are they at with openAPI. So a lot of good sessions in the afternoon, and then we're going to wrap it up with a contractor panel discussion. Ray Hopkins from Caltrans is going to facilitate that discussion. We have 4 contractors that we're really trying to get their input. You know, what do they need to be successful with openBIM? And then Roger Grant's gonna finish us off with the FHWA Digital Delivery Stakeholder Group. So we've really got a packed agenda today and really looking forward to it. So with that, I'll go ahead and turn it over to LeapThought, one of our platinum sponsors, just to give a quick overview of what they're up to.
Nice mic. Yeah, I appreciate that. Hi, everybody. Very good morning to you. Thank you, Building Smart, for the opportunity, and thanks to DOTs and the rest of the sponsors and everybody else that took the time to come to this event. So Open Standards is very special to us because we believe for asset owners and operators being able to get into the trenches of your data, both graphical and non-graphical, unlocks the potential that we're not seeing. So we've had the fortune to work with a number of asset owners and operators worldwide in really supercharging the way that they design, build, operate, but also enhance and extend the economic life of their existing systems, processes multifold. We do have active references. We do have site tours that we can organize for you guys to come and take advantage of. We'll be collaborating with a lot of you guys into the future. I personally, I like transportation sector because up to, I think, of the $300 billion worth of infrastructure that we power through our platform, I think $80 billion is of transport. So that includes highways, that includes rail lines, tunnels, And yeah, so these are quite complex infrastructure projects. So we do have examples that we can share. We actively collaborate and do a significant R&D with the likes of Amazon and Microsoft. I sit in Seattle and I kick them every day because basically, as there's the clouds evolving, as the compute power is basically becoming more accessible, I believe basically the construction sector has not been taken advantage of it to the extent that it can. And to that extent, we're like basically Netflix. When we vectorize all the graphical data of potentially a rail line or a highway that cuts across a city, we need significant compute power to be able to sort of process all that and make it available for all the stakeholders in different contexts, right? In a location and context-aware manner. So, yeah, so I just wanted to talk about this slide. Yesterday, there was a discussion about ISO 19650. I'll just spend 2 minutes talking to this. If you think of what we do, the philosophy is actually explained in this. We're not actually reinventing the wheel. We're actually taking advantage of a standard and a philosophy that's been well basically established and matured. The notion of ISO 19650 is basically you've got a scope of work. You have basically the project information models. Eventually, they become the asset information models. The way they evolve and the level of detail increase as you go through the life cycle means you need basically traceability. And there's got to be a chronology of how things evolve. To achieve the traceability, ISO 19650 basically gives you the guidance as to how you can get to that single and trusted source of the truth and how you keep evolving that story. But the key to that is going from 2D to 3D is going to be a complex kind of a transition. So without the complementary kind of abilities of machine, it's very difficult for people to actually make the transition, because looking at a plan on a piece of paper versus comprehending something in 3D takes effort. But with the help of machine, being able to basically do the quality control on behalf of people and infuse the evidences that it captures back into the browsers of users, taking advantage of the ISO 19650 gives you basically the cradle to cradle kind of opportunities that open up. So later today, LeapThought had the pleasure of receiving the models, the Iowa and PennDOT models. Our team actually have put it through the system, and we'd be able to show later, how our system basically could take advantage of the models and what it could do with it, including the AI and ML. So yeah, on that note, yeah, have a great second day. I'm Ratnakar from LeapThought. Thank you.
Good morning, everybody. John Starr here, Nebraska Department of Transportation. I'm the digital delivery manager there, and very happy to be here in San Diego. I have to say, Southern California has a really strong coffee game, so that's dear to my heart. I've been up early in the morning walking around, but I think we're ready to go here. The theme of the session 5 that I'm going to be moderating here is openBIM in action, and it's really geared towards the ADCMS report out. We heard about the ADCMS yesterday, how important that is. So I have the pleasure of introducing a couple peers of mine from Pennsylvania and Iowa and their consultants, and how they're advancing what we're all trying to get done here through ADCMS. So I have Alan Melley of PennDOT, Joe Brenner of MBI. They have 15 minutes, and I think Joe agreed to answer any questions you can throw at him about Penn State football this year if there's time at the end here. So we'll turn it over to them.
Below the belt. How about it? Ouch. Appreciate the opportunity to talk about PennDOT's ADCMS pilot projects, where we utilized IFC as the contractual documents to deliver some of our projects. So Joe and I will give a brief overview. I'm going to give a little bit of background of PennDOT's digital delivery directive and how we got to where we are. And then Joe's going to dive a little bit deeper into exactly what we did and how we developed that and delivered that those projects. So as we look at digital delivery, we started out in 2019 with our vision to, by 2025, construction projects will have the ability to be bid using 3D technology and no longer be in that traditional construction plan format. So we hit that goal at the department. So we set out with that goal in 2019 and achieved that by 2024, actually. So one of the department's goals, though, with that vision was to be data agnostic. And, you know, that's been something that we've been striving for the whole way through. And with the opportunity of the ADCMS grant, we were able to help advance that, that goal that the department has. So our directive, again, started out with small projects very early on. Wasn't that flip of a switch. So we tried various aspects of digital delivery, a lot of hybrid type projects. So our first one was, you know, where we just modeled the earthwork and pavement structure. So eliminated the cross sections. So it was just that, you know, introduction to digital delivery, the introduction of digital delivery to our contractors or our inspectors. So anything they needed off of the cross sections, they had to go to the model. Everything else was still in plan 2D paper plans. But as we advanced, we delivered then 2 bridge projects, complete structure models, no, you know, no plan sheets whatsoever. They were still hybrid. So on the roadway side, there was still, you know, the paper plans. So then we continue to advance. The next step was the drainage and utilities. So we have projects out there that, you know, added the drainage and utility aspect to, you know, digital delivery. And then each of our districts was required to have a model as the legal deliverable project. So complete model deliverable. We have multiples of those actually currently. One's advertised, another one, a couple were going out. We have one in construction. So we are making progress and we continue to advance along. Now, the ADCMS grant were opened up. We were one of the first round recipients of that grant. And we felt the need to advance that IFC deliverable, that open data standard. You know, going back to those original goals of the department. So we selected 2 projects, a steel structure and a concrete structure. So again, different types of structures, but still those workhorse type structures that we are used to building day in and day out. So these aren't the mega projects or, you know, those one-off, you know, specialty bridge projects. We were looking at our bread and butter type projects that we can do and create a repeatable process. So we decided to, you know, again, test what, you know, the BIM for bridges and structures pooled fund has really developed, put that into practice, see what works, what doesn't work, and help influence, you know, where they need to go and what changes need to be made. Because the only way you're going to see that is if you pilot these projects. So we took the leap and went that direction. We have both of those projects currently in construction. So they were bid and let and very close to the engineer's estimate. So as we continue on, you know, we hit that 2025 date for Pennsylvania. What does that look like beyond? So we are starting to institutionalize digital delivery at PennDOT. So we have 11 districts across the state. Each district in 2027 is required to deliver 2 projects. 2028, 3 projects, 2029, 4 projects, and 2035 projects. So you can see it's that ramping up of digital delivery. And, you know, there'll be 55 additional projects come 2030. Now, we also set that in 2029, any integral abutment bridge projects less than 90 feet in length that are started in 2029 have to be done digitally. 2030, any new construction or reconstruction projects have to be done digitally. So we, you know, are starting to institutionalize digital delivery as we continue on, and the open data standards is going to play a big role in that deliverable. So our, you know, ADCMS grant was really, again, to improve that data interoperability. test those IFC models. One was, for information only, but the other project was contractual. So the contractual documents were the IFC files. And it really helps us advance, those mold projects. So these projects are complete, model deliverables, and delivering that IFC file as contractual for the bridge elements on the steel structure and for information only on the concrete structure. But with that, I'm going to turn it over to Joe. Oh, no, I'm not. I still have 2 more slides. Sorry. So why is it important that that we're actually doing this? So today, we're using our proprietary software, delivering it in that file format, and then the contractor has to take that format to, put into his equipment or to utilize that. And he's stuck in that ecosystem, that exact product line to really utilize it without, much trouble. So what do we want to achieve? We want to be able to achieve where we can design in whatever software. And that's the department's goal, is we do not want to dictate what software platform our consultants or our contractors have to use. Because, utilize what they have developed, what they have invested in and trained their staff in and so forth. We want to be open. So, as we go through, this is where we find, IFC to be, that interchangeable standard that, we can design in whatever, provide that as an IFC, and then the contractor can then take that IFC file into their equipment. There's not the manipulation like it is in a standardized proprietary file format. So with that, I believe I turn this now over to you, Joe, to get into our pilot project.
All right, thanks, Alan. And I know even, between the various events that have happened here, probably everybody has heard of this project. Even from the sessions yesterday, it was mentioned, and you may have even seen some presentations on this before. So we are going to go through some of the base information, the foundation of how it was built, but we're also going to get into some new updates and some additional content. So if you have seen this, a presentation on this project before, don't completely check out on me here. All right. I know we've had a string of events here with IHEAP and everything, but we do have some updates here. So first, Alan mentioned the ADCMS and specifically the objectives here. And just to hit on a couple of the highlights, the first is we are, looking at that testing, a proof of concept of what the BIM for Bridges Pooled Fund has developed, right? So the IDM, IDS, BSDD, insert your acronym here, right? So that was a key component of this from our perspective. The other thing I just want to mention, and it was said earlier, I think yesterday as well, from Will, but just the overall collaboration with the Bridge Pooled Fund, the Iowa ADCMS team, the states, the software vendors. Without that, this could not have happened in the timeline that we had. So I just want to make sure I mention that and say that from our perspective, that was huge in terms of delivering our goals here. And as Alan mentioned, particularly for this project, we wanted to make sure that this IFC is the contractual model, right? There's a lot of benefit from having that the files for information only, those exports for information only. But when the model is a contractual document, we wanted to show here that without this content, without this IFC model, the contractor could not build this project, right? So we're forcing their hand a little bit, if you will, but we really wanted that to test and fully test out what's been developed here and what we can do with this proprietary format, or with this, with this openBIM format. Strike that from the record there. I don't know where that came from. So as Alan mentioned, this is, look at not only this project, but all of the ADCMS projects. They are typical workhorse projects, right? We're looking for that consistency to be able to do that, not the one-offs on the big cable say type structures. Again, not that that's not beneficial, but we're looking for a repeatable process. And I think probably every owner in the building here, bridge owner in the building here, what we're showing with these projects or these types of bridges make up the bulk of your inventory, right? So we want to make sure we're on that end of the spectrum. Also, we want to build on some of what's been done already in terms of openBIM, right? Going back to even the first BIM pilots, Utah DOT, I don't know if Cheryl's here, but The first Black Rock project that Utah DOT did, 6 or 7 years ago, we actually provided the IFC files, IFC exports for information only, even back then, right? That was to work with some of the contractors, software, the fabricators in particular, just to be able to do that interoperability piece. So that's been done. You can see some examples here on the right-hand side of my screen here, where some of the, even if the receiving software said it can import native files from other software, we were seeing some discrepancies there, even in the geometry on both cases. So, and the way we solved that was with some IFC exports, right? Like geometry come through, but we want to build on that approach that's been used for years, right? And now we're getting into more of the metadata, the non-geometric information properties that are coming through, as well as the structure that we're going to go through here. So we want to build on that. Obviously, we want to test the IDS. Particularly, we wanted to look at identifying any gaps that we were seeing within testing the products that were out there. And PennDOT, as Alan mentioned, has been doing bridge pilots now. There's been several iterations of that, and we have property sets for each bridge element that we've been developed that have been used in construction in these other pilots. So we were able to kind of look at that and say, okay, this is the information that we're saying we need. This is this compared to the IDM and the IDS that was compared from the bridge pooled fund, and look at, okay, maybe there's some things here that we want to potentially incorporate into the national standard, but then maybe there's some things that's just PennDOT specific that, it's just things that a state specific is going to need, and we're going to always have that. But looking at what's the differentiation there, but also then how do we incorporate that state specific needs outside of that national standard, right? That's important too. And so we've got to test for that. And I don't want to miss the point here. At the end of the day, this is a real project that we have to deliver, right? This is a bridge project that has to be built. So we need to make sure that we have a usable deliverable, even in this transition period where we're testing, right? So, and I think that kind of drove a lot of what we do. It drove the timeline. I mean, we have deadlines that we have to hit for the project in order to get this out. So that again was something that we kept kind of high up in our mind here, that even in this transition period, we got to make sure what we're producing is actually usable within the field and beyond. So Alan mentioned the two PennDOT projects here. There's just some images of the actual models. The SR 3010 bridge was pre-stressed ball T-beam, single span. Designer was JMT, and then that was the IFC for information only project. And then the SR6 project that we're going to go over here today, that is a 2-span steel plate girder, and Michael Baker was the lead designer there. So again, still, we're looking at multiple different beam types, but still within our general workhorse type project or bridge framework. So here's just a little bit more details here on the project, on the particular bridge. As Alan mentioned, kind of this has been advertised and let here. So as of now in September, a couple months ago, we have that let. We have a contractor on board, had kickoff meeting, and construction is, I think it's scheduled to start in February, March timeframe. So physical construction, right? So we're in this kind of time frame now where we're going to be prepared and meeting with the contractor, but just to give you a little bit more information on timeline there. So specifically tools. I've learned from doing these presentations that all the questions seem to come in on software. So I thought I'd try to get out ahead of that a little bit here and talk a little bit about that during the presentation. And we'll get into more of the different tools that we used and why we use them and where we use them. But the point I wanted to make on this screen is that we are also providing 2D details, right? There's just certain things that's more readily available, consumable with this content in a 2D detail format, right? So we're not trying to cram 3D models down everybody's throat for everything, right? It's kind of like our 3D models are hammer, everything's a nail type thing. We want to make sure that we're giving the information in the most usable format possible here to improve and help the process, add value to the process, right? So there are 2D details that are associated with that. They are in a digital format, right? So they can still use the same viewers. They don't have to go to a paper PDF plan set or move different platforms to use it. But there are specific 2D details that supplement our IFC or 3D model in general. So this is just a kind of a brief software diagram here, process flow, if you will. And we've tried several different approaches, and I'm sure Grant will get into a little bit about their approach here and their pilot project. But what we ended up using was openBIM for what I call our solids, bridge solids. So that's all of our abutments, decks, barriers, anything related to the solids of the bridge. And we used Bentley Open Bridge Modeler / Pro Structures here for the rebar modeling. We'll get into why we chose those specific tools. But the real key is that all of these come into the IFC deliverables, right? So at the end of the day, that's our deliverable for the project. We're using that to test within the IDS and the BSI validation service for use in construction and beyond. So a little bit of overview specifically on the openBIM software tool. As I mentioned, this is for our solids modeling. Some key features here, obviously parametric modeling, that's any bridge modeling software nowadays, that's a key feature here. What really was important for us on this is they had already built in some of the IFC export capability based on the early releases of the Bridge Pooled Fund IDM and IDS, right? So they already had that incorporated in their software. It gave us a much better starting point to do that. Collaboration was great, being able to get feature enhancements. And again, the key part of that with openBIM was their ability to turn around improvements that we needed quickly. And I'll go over that here in the next few slides. So here's just an overview video. Do that. Hopefully that comes through. So this is the openBIM software, our bridge within that software. Again, similar process here with parameters entering in inputs. It's kind of more of a spreadsheet layout, which again, as a bridge engineer, I like my spreadsheets, right? So familiarity there. But what we're pulling out here is the specific IFC tab that they had developed previously and enhanced during our project, where we got to have some key classifications that were already made and make adjustments there in terms of how we were mapping these elements to the IDM and IDS content. And it had some of the standards and built-in ways that we could very quickly bring in the IDS content that was there. So we were able to consume that format and be able to check things right within the software before we even exported to, kind of take a look at compliance there, as we were in the native model authoring software, as well as being able to add not only the specific content in terms of property sets from the IDM and IDS, but also custom from PennDOT, like we mentioned before. So just some further observations here. Again, many may not be familiar with the openBIM tool. The ability to already have incorporated this content within their software, especially the spatial hierarchy. We'll show that here in terms of being able to slide these elements in the right places, if you will, within that structure. They do have minimal reinforcement modeling support, so we'll get into that here in the next few slides. But the key component of them was being able to be flexible and nimble. And many times we had updates we needed from things in the morning, and by that afternoon or the next morning, we had updates pushed from their cloud-based software to make sure that we could meet our deadlines. And that was really the key component within this, was having what we call a clean IFC 4.3 export, right? We all know IFC is really just a text-based file, right? So you can get in and manually modify that, and that can be done. But with the turnaround times that we had between checking, reviewing this content, and to hit our deadlines for the project, we felt like we needed to have something that we could, again, hit the button and make updates, hit the button again, and have that clean IFC export that we didn't have to take out to a third party and manipulate that text file or within a different software. So that was, again, really key to our success in this project here. And I mentioned the other ones in the previous slides. So I did mention Bentley OBM, and we use that to model and export the rebar components. Again, this was, I guess, where are my bridge people at, and who has modeled rebar before? Couple, okay, couple in the group, okay. So, and those probably would tell you, I would think, and we'll see some head nods here maybe, but that is not something you want to do in a less mature software, right? Rebar modeling is a tedious process, even with the best software that we have. So we wanted to make sure we had a mature software that we could model and be able to do that. And again, with openBIM at this point, we wanted to make sure we had that. So we went with OBM. The other part of that is some of the limitations we had within OBM exports to IFC for some of the bridge elements. They have been incorporated rebar in the vertical construction here in IFC exports for probably decades, you know, so, and rebar is rebar, right? So whether it's a bridge or a building, you know, that content, that background, that structure for that export was already there. So we were able to get a clean IFC export specifically for the reinforcement there with them as well, to keep that going. So that was, you know, being able to use some of that. And again, with Bentley's or with PennDOT's work with Bentley and previous engagements for the other BIM pilots, we had already had some rebar modeling enhancements in there to automate some of the item types, bar marks, those types of things within the software. So that's what we used there. So here is just a quick video of our abutment rebar modeling. So you can see here, that's a pretty congested, we pack a lot of rebar in there. It's amazing that they can get concrete in there sometimes you see that, but just kind of pulling in and looking at one of the specific rebar sets. Again, as I mentioned here, we have our item types already established for the PennDOT workspace. So we're able to pull that in and automate a lot of that. And then also be able to export that into the IFC file, model export, as well as some of the other ACI and other property sets that come through as well. So a couple components, just wanted to get into the actual IFC model structure here. One of the key components here is the spatial hierarchy. This is something that, again, has been talked about for the last couple of days and many times before here, but this was key not only for the structure and to match an IDS and be able to kind of find that structure, but where we saw this really helpful is when we got into adding property sets. There are certain things that we wanted to property set at more of a assembly level, if you will, down to a detail component, right? So a great example of that is girders, our bridge girder, steel girders. We wanted to have some properties associated with the entire girder line or even the girder group set, right? But we also wanted to have some properties associated with the girder segment from field splice to field splice, and then even down to the specific plates, right? So within this structure, we can now add properties at those different levels, which was extremely important for us in terms of being able to check that, as well as from some early feedback we have from the fabricator. As we mentioned here, now those properties are coming through not only our IFC specific properties, if you will, but those custom property set that we've developed and wanted to include here within the project. And then here is just again a quick video showing that content. This is just showing in a regular typical IFC viewer, free IFC viewer. It shows again that consistent hierarchy, and many softwares do have their own hierarchy, but now we have again a way to have a consistent export and a way to get at different assemblies. There's the total girder line assembly, and now we can get down even to properties there, including some of the camber details, those types of information, camber ordinates from different phases that can be built in now to a digital file, which was, again, something that the fabricator really liked, that they don't have to get their plan set and start typing in all of our camber details for the different situations there. And then another video here. This is actually just the content with the Bridge IFC file export within the Bentley infrastructure cloud environment. So this is the software that PennDOT is using and providing free to the contractors at this point. But it shows not only, again, our Bridge IFC content, but it shows it with our roadway environment, our approach roadway information utilities, all now still within that DGN format. So now we're really looking at kind of federating all that information in within one environment, all the different disciplines here. So now we can still utilize some of these viewer capabilities enhancements with things like Bentley has the data visualization and filtering and be able to isolate different components, including pay items or specific bridge elements. Our properties are coming through now. We utilize save views, which is key. I'll get into that a little bit later, but now we can use that within the viewer property to create save views, which has been really big for contractors, especially those that are not CAD savvy, trying to go through a CAD workspace and look at different levels. Now we can be able to turn elements on and off within this environment and save those views so they can have easy access to that, even in the field. So quick few slides here on model validation and some of our quality control. Again, with the program, with the infrastructure cloud program, we're able to utilize the issue logging with forms that's been established. So even with a new file format, we can incorporate that and still use all these tools that have been established and now are maturing. So that was a key component for us too. As I mentioned, especially with the turnaround times that we had, being able to have that that content there and utilize these tools was very important. I mentioned the BSI validation service, getting that clean export we were able to kind of work through. We had a few issues there. This is one of those things that we went back and forth with openBIM and the software vendors and got that fixed up so that we could get those clean validation reports directly from our exports. IDS, same thing, be able to go through that components and be able to make sure that our files were passing the current version of the IDS content. I know that's being updated and enhanced here, but we were able to kind of show that as well as far as the testing process. So to wrap up here, just a couple of benefits. As we mentioned, as a designer and as Alan mentioned, we were able to use multiple tools, multiple model authoring platforms, and use what we felt was the best tool for the job, right? And I think that's one of these main benefits from openBIM in general, right? With that, the ability to kind of use that. And again, we were able to kind of show that even though that might not have been the intention when we started out, able to do that with some of the needs and be able to test that, right? Again, testing, and hopefully, as we talked and worked with Grant and the BIM pooled bridge for Bridges Pooled Fund, able to validate certain components and look at potential extensions of that from what's being developed there. Again, with the customization for state specific needs, I think that was important to kind of go through because again, every state's going to have work on top of this national standard to add some specific things that they're going to need. And again, with the ability to work directly with these stakeholder groups to create this project and the timeline that we had, I think that was just a huge benefit through the entire process. And PennDOT has really done a great job leading that throughout their process, not only in this particular project. So some lessons learned, right? We're not going to get this right the first time, right? And I think we already kind of knew that in the back of our head. Some of the things that we did this and maybe not even the second or third time. This is going to be an evolving process, right? And we're going to get better. We're going to look at these different aspects. Every project's a little different. We're going to have different things that we're looking at, right? But we also don't have to wait for specific tools to be developed to do this right now with this process. And we don't have to wait just in general for everything to be perfect to get things done. And that's one of the things that we definitely felt like we proved through this in order to create a viable product here. And one more thing I'll say is, there's differences in how software imports and exports IFC files, right? So especially when we get into these later, 4.3 type versions of it. So the importance of, looking at this early on and getting, certain aspects and software vendors on the same page in terms of how we want these to be viewed. Because again, the IFC is very flexible. So there's a lot of different ways you can do the same thing, right? So we want to get on the same page on how that's used. So just as a wrap up here in terms of what I'll call IFC use enhancements. I had IFC extensions, but I know that means a lot of different things to different people here. So just in terms of the use, and this is more, not necessarily within the schema, but, maybe again, as viewers, and how we can help to get on the same page. But that was the top one that we have was the ability to have specific views. And Bentley calls them save views. We were able to do that within the Bentley software for the files and the overall process. But the ability to have that stored within an IFC file so that when, the contractor A or fabricator B gets this information, be able to have those same views accessible within the IFC file, not specific to the viewer, right? And I think that's going to be critical moving forward. I have some notes there on some things that I think would be extremely helpful. But again, that has been a key component to being able to use this information, right? Especially in the field with non-CAD users. And some other things and again, I know this can be done here, but efficiently and effectively merge or federate different files. And again, especially when you start talking about contractual models, that is something that I think something that we have to take a look at and maybe get a little bit better at when we start looking at, because we're not going to have that whole big federated model, at least in the meantime, where you have everything together, you hit a button, there's going to be different components, different disciplines working on different aspects of that. So, just effectively merging those files. And then finally, the ability to have kind of a use case based or role based grouping of elements, hierarchies, being able to see that, and the visibility of property sets. So this is one of the specific updates that we have just last week talking to the fabricator. They were able to go ahead and create their own property sets out of that, which is great. We want to be able to do that. But even within, they wanted to look at some specific groupings of elements within the hierarchy a little bit differently than it was set up. But again, that is something that I think is an enhancement. They were able to do it in a roundabout, a little bit of a workaround way. But some things to consider as we go through, and I'll beat my drum as we continue to talk about that as we find updates and ways we think we can make this process better. So I think that's all we had, and we have our contact information. I think we're holding questions till the end. Is that correct, John?
That is correct. Questions at the end of the session. So big round of applause for PennDOT. So we're running ahead of schedule. Thomas, you get an extra 15 minutes. I hope you're working on your PowerPoint there. But I will introduce our next presenters. We'll be speaking about the Iowa DOT ADCMS project and their advancements. Will be Thomas Hamski from Iowa DOT and Grant Schmitz from HDR.
All right, thank you very much. As I said, my name is Thomas Hamski. I'm from the Iowa Department of Transportation. I work in the Bridges and Structures Bureau. My official title is Bridge BIM Engineer, but I basically do a whole lot of different hats around the agency. And I was lucky enough to be able to manage this large federal grant as well as another large federal grant we got, as well as an aid grant. But what we're talking about today is our process. We went and we got an ADCMS grant similar to what PennDOT did. And I think it's very important to show that Federal Highway saw two very similar projects, but they funded them both anyways, even though there's a lot of overlap with what we're doing. But I think it's very important to be able to get to this information where we are focusing on that data exchange to seamlessly get information flowing around. If you've seen me present before, you've seen my little circle of life that I like to call it, that information is flowing around, and we're really focusing on the bridges when it comes to this project. Part of our grant is also focusing on pavement, but we're not going to talk about that today. We're just going to talk about the bridges. But the important thing is everything needs to flow through. And what PennDOT was showing a little bit earlier is needs to be that seamless exchange of information, because oftentimes other versions of this, I've got little X's on the exchanges, because from design to construction, you've got PDFs. Those PDFs go off somewhere. They get buried in a cabinet, whether virtual or in an actual physical cabinet somewhere. And that information just needs to be repeated back into asset management. And As we pass this information along, we want to be able to get to a point where we can actually share information without having data loss, without having to have that extra step of manually inputting information back in, going back to our systems. So we can actually find information about our assets. And that's the important thing. With our project, we wanted to do a proof of concept of the phase 1 deliverables from the pooled funds for BRIM for bridges and structures. So testing out the IDM, IDS, Building Smart Data Dictionary, really focusing on what the pooled fund was able to develop. Can we put that in action? And that was one of the focuses of our project, was to do that. We wanted to assess how IFC could be utilized to deliver a project. Our intention was to do models legal document like PennDOT, but I'll talk a little bit later in the presentation, had some complications when it comes to doing Malden, Iowa, or at least for a bridge. We wanted to encourage integration of IFC 4.3 into software platforms, and then collaborate again with PennDOT and the pooled funds and software vendors to really make sure that what we're doing is reaching the masses, because it's very important to do these steps. We need these guinea pigs to go onto the edge and say, okay, I'm gonna take this leap. I'm gonna figure out what's going on, and then share the information. We chose a project that was very simple, similar to the structures from Pennsylvania. Oftentimes when we've done pilot projects in the past, we get that question, why do you always use the most complicated projects? In 2018, we did another mold project on a bridge structure, but it was curved steel beam. There was a lot, Grant also was involved in that project, and there were some complications with that. So lots of things that we learned how not to do pilot projects. But so for this project, it was pretty simple. I mean, we wanted to avoid any problems with having to do complicated rebar design, complicated beam design, complicated geometry, those things. So zero skew, no aesthetics, no staging, as simple as we can get. There's some downsides to that, because a running joke I have with one of our construction folks is there's 3 different types of bridges we build in Iowa, and all the contractor needs to know is what type of beams, what's the elevations on either end, and then they can just build those bridges. And that's kind of what this bridge is. It's one of our cookie cutters, but I think that also gives us some advantage because there's not a lot of complexity to it. So we can really give the contractor some time to engage with the model and learn and give us some feedback so we can figure out, okay, what's working, what's not, because IFC isn't going to replace plans overnight. So the schedule of our project, we kicked off in September 24. September 25, we were advertising the project. We awarded it last month. And now I'm just sending an email this morning to start engaging with the contractor to kind of figure out our pre-construction, where we're going to train them on the model, give them some information. Oh, internet connection is unstable. Sorry, I got distracted by something shiny on the screen. And the process is we have our designer on contract to continue to help us with the project as we're going through. And Grant's could talk a little bit more about that. So here I'm going to hand it off to Grant to kind of talk a little bit more about the nitty gritty of what he did to make the project work.
All right, thanks, Thomas. Like Thomas said, I'm going to take a few minutes here to kind of dive into the details on the process. Not getting too deep, but try to, stay high enough level that, it makes sense for everyone. And I'd be happy to talk after with anyone that wants to get a little bit more in the weeds. I think you're going to see a lot of the same topics or workflows that Joe and Alan presented right before us. And just, I want to reiterate the collaboration between Michael Baker, PennDOT on these projects. It was really helpful, and I think it helped us move forward with a more unified voice. You've heard that before, as well as we communicate with Bentley and other software vendors. So I think that's a really important thing to note there. So we started early on in this project by reviewing the Bentley products. Iowa DOT uses a lot of Bentley products in the state right now, and we wanted to try to leverage those. So those specific products were OBM and Pro Structures. And we wanted to see, how did they work with IFC? So what we did find was that they do have some IFC 4.3 support, which was obviously step 1. And they had some ability to do mappings to the different IFC entities. And the way they do that is through item types. And I believe that's still the way that process is handled. And we were also able to get out custom properties and property sets using item types. We also identified some challenges with the Bentley products in terms of building out that spatial structure that you saw Joe mention, as well as, how do we connect objects modeled in OpenBridge Modeler and then Pro Structures. In our case, that was where we did our reinforcing modeling into an IFC file, because everything within IFC is related and follows the spatial structure. It doesn't always align one-to-one with what a software vendor may have currently and where it fits within the IFC workflows. So if you can't tell already, we collaborate not only on the projects, we collaborate on our presentation content as well. This is very similar to what Joe has in terms of a workflow. However, there's some slight differences, and hopefully, the way you saw it in Joe's, it helps make sense of this. But I've identified basically the checking mechanisms in yellow, and I've tried to identify the software products that we're using and the tools that and go with that in orange. So our preliminary approach was, again, to use OpenBridge Modeler from Bentley as well as Pro Structures. OBM was our concrete, Pro Structures where we did our rebar, miscellaneous steel, such as our steel diaphragms. And then we enhanced that with item types. Our hope was that we could, work with Bentley to get a clean IFC 4.3 export, get that to process, get all those green checks that we want to see from the IDS check, and then get those green checks in the validation service, which you've seen a few times already today. And then roll that forward into third-party construction software, test that out, make sure that we were comfortable with what the IFC file was presenting in those other construction software tools. I do want to give a shout out. I know Alan's out there somewhere, at least he was yesterday, as well as some of the other folks at Bentley. They were a good partner working over the past 9 months to a year now on this. We had many meetings. I think it was monthly or bi-monthly at some point between the PennDOT project, Iowa DOT project, and Bentley trying to work through some of these issues. Most of our issues focused on developing the spatial structure, and they did develop some custom tools for us to push that out of OBM. However, there's many enhancements that we still need from the products. It was a long list of things that we needed to implement, and we understand there's challenges, especially with the larger software companies, that it takes time to get these new workflows into their products. So I have a list here of things really at a high level, and it's kind of a mix match of different things that I was thinking of when I was putting this together of what we need to do going forward within those products to really support a clean 4.3 export. So looking back at that preliminary approach, we needed to fill in the gap. We understood that we couldn't get a clean 4.3 file directly from OBM and Pro Structures. So we needed to find a way to manipulate those files to get all those green checks that we needed. And in our case, and this is where we really differ from PennDOT, is we used a free tool, which is Blender with a Bonsai add-in. If you want to get familiar with IFC, you want to learn about IFC, I encourage you to download it. It's a little more complicated, but it really gets you to understand IFC and the structure. It's a native IFC authoring tool. There's a lot of power there. And I think we learned, we learned a lot from the tool, just exploring the different facets of the user interface. So it was a really good experience for us. Here's just a snapshot of Blender. This is one small part of it, but again, just kind of highlighting the different aspects that they present in a really easy to use way for a non-technical person such as myself. They identify the IFC entity that can be modified and changed. They give you all the attribute information. They make it easy to adjust the spatial containment. as well as the aggregation of elements. So for example, in a cross frame, or Joe, you mentioned the girder example where we may want to aggregate flanges and webs or members of a cross frame into an element assembly, or an element assembly. And then also they allow you to customize properties and do a whole lot of other information, a whole lot of other items that are available within IFC. So some of the advantages of Blender and Bonsai, like I mentioned, there's broad support for IFC 4.3. It resulted in a clean 4.3 deliverable. Again, all those green checks. It's free, so you don't, especially if you have troubles procuring software, if you're a DOT or an agency, hopefully this is easier, maybe not. Whether it's free or not, maybe that doesn't matter as much. But and lastly, it freed us of vendor implementation schedules. Like I mentioned, we could make these changes on our timeline, and we didn't need to rely on, in this case, Bentley being able to get it in on time, or other vendors. Some of the concerns, there's limited automation here to a certain extent. There's a lot of power, I think, with scripting and other things. I wouldn't say that this is a long-term solution, but it's a solution for us to get a good example data set out there for use. And it is a complex user interface if you're new to IFC, but again, I think that really will help elevate your experience and understanding of how IFC is structured and works. And I think I'll end here with just a few random screenshots of different platforms. This one is BIM Vision, again, showing the spatial structure, showing some of the attributes and properties that are involved here. Some of the software that we used during construction or assessed during construction, Trimble Connect, Contenda, Deluxe, Propeller, USBIM, BIM Vision. Some of these are paid platforms, some are free, particularly BIM Vision and USBIM. But we really wanted to understand what the contractor was going to see downstream. We didn't want to just create a clean file and say, here you go, contractor, good luck. And hopefully you can find a platform that reads in the IFC in a way that makes sense. So we needed to validate that for ourselves. What we settled on, there's a lot of good platforms here that support 4.3. We settled on Trimble Connect for this particular project, really just because of where they were at with their 4.3 implementation. We felt comfortable with really the Trimble name on the construction side. We felt that they integrated a lot of other tools well. So we decided to move forward with that. And again, we're not mandating the use of Trimble Connect. We're just making a recommendation of what we've seen and what we've worked through. A few more screenshots. This is from Trimble Connect. I think you maybe actually have seen this screenshot either yesterday or the day before, but there's a lot of power there in being able to dimension objects, save views. I'll reiterate what Joe said about if IFC could capture saved views, that would be a huge improvement, because right now we are locked in to a particular platform, and we need to develop those saved views once we pick a product. So we'll be doing that as part of our construction support. Once we know what the contractor chooses to use, we'll develop a list of saved views for them. Another screenshot of just a section cut through the deck. I'm trying to show a level of detail here with the reinforcing and the pre-stressing in the pre-stressed beams. And then to summarize my part, we were able to produce that file with a variety of tools. We passed the validation service. We love to see those green checks. And we want to use this model to improve IFC integration in a variety of software platforms. So with that, I'll turn it back over to Thomas to talk about the construction side.
Thanks, Grant. So with this project, we realized that there is a huge effort when it comes to bridge contractors from trying to figure out, okay, how do we actually use this? We knew that we would have to engage with our contractors, and that's a huge part. We listened to the AGC and ARPA talking yesterday about various things they're trying to do to engage their communities, either nationwide or locally. And that's important. So we started out early this year, early this year, engaging probably every other month with the AGC to kind of talk about, okay, what do we need to do? And our intention, as I said earlier, was to do models legal document. We really wanted to focus on that. So the contractor had to engage with the model. We came to a crossroads April this year, really realizing that we didn't have a model that was fully developed yet, because we were still working through the engagement with Melley, trying to get to that point. And so we said to the contractors, okay, we're gonna do this FIO. We're gonna do it for information only. And we had to do that because there's just too many unknowns for the contractors to really be able to want to engage. By July of this year, we got to a point where we finally had a model. We had the Trimble Connect platform up and running for them. And then that engagement, we got one contractor that was really light bulb moment. He came in, he's like, wow, I can do so much with this. How come you didn't show me this earlier? We've always been talking conceptually. When we had something in their hands that they could use, they could see, that's where they started to see what this really is doing for them. They were already familiar with Trimble, and we've gone through this whole process, like Grant said. We're not mandating anything. We wanted to work with the contractor to use the same software as much as possible, but we weren't going to tell them, you must use Trimble, you must use Bentley, you must use LeapThought, you must use Contender, whatever. We wanted to say, okay, this is how we're doing. So we didn't want to get to the point where we had information just kind of going all over. And our past project we had, as I was saying earlier, those as-built get kind of scattered. So we wanted to be able to have something that was be able to be transferred off to asset management later on. So historically, we've had a lot of resistance in Iowa to going mold, at least on the bridge side. I think I've said this before, but our bridge folks said something to me early on in this engagement. Our guys build with their hands and DeWalt drills. I can't plug a USB drive into that and have an automated thing doing anything. And that really hits high stride with me, because graders and pavers, they can plug it into machines. Those machines do the work for the most part. When you've got builders with their hands doing things, it's a lot more difficult to see the advantages. So we wanted to make sure that we engage with them and get to the point where we weren't giving them the risk that was unnecessary. We didn't want to do that. We wanted to take on the risk. We wanted to be very flexible for being able to do future enhancements. So when we did information only, that's what gave us that ability to basically kind of have a conversation with them to say, figure out what we can do. I mean, but there is that disadvantage, like I said, of we're not requiring them to use it because it's not the contractor plan. So we have traditional plans with that, and we didn't want to focus on forcing them into something that they weren't going to be ready to. Because I think I've said this before. When our contractors get grumpy about being forced to do something, they call the governor, and the governor calls our director, and then we get shut down. And then that doesn't get anything going on anymore. We don't want to get politics into this. We want to have that engagement. So how do we get them to engage? We try to give them a carrot. So we paid them to engage with it. We're starting that process, hopefully later this month, to kind of start meeting with the contractor, engaging, getting in regular meetings with them to say, okay, how can you use this? What do you see that's of value? We have a contractor that has not done a digital project with us before, so it'll be, I think, a good experience working with someone who hasn't had one of our digital projects. So it'll be a brand new experience for them, brand new experience for us working with a new contractor. And we think that giving them that carrot is going to give them information or the ability to engage with us. We're also trying to see, we've got this model. We want to say, okay, what else can we do? So augmented reality, various things. So we had to wanted to get a field operations set up out there on this project to really kind of try to do more with the model than just say, hey, here it is, it's replacing plants, because that's not going to happen. So in conclusion, I mean, Joe said it beautifully. We got to have those things that replace paper. There is major issues when it comes to building things. There is grease, there is dirt, there is rain, there's mud. There's so many complications that there's data problems. A piece of paper doesn't have its battery die. A piece of paper, if it drops in a puddle, you can print a new one for 5 cents. You drop an iPad or a $5,000 data collector down in a river, that's a big problem. You don't want to have those situations where things going on. So I don't know if paper will ever 100% go away, because there's certain things that it's very good at. But that's not the being said, there is still progress being made. As I said, the contractors, when they're shown and given something to use, that is when the proof is in the pudding. I think they're finally seeing that there's some value to it. Some discussions I've had throughout the week is when the contractors see that they can make money on this, that's when they're going to embrace it. And then if they can find the efficiencies, like I said, making money, they're going to want to utilize this as much as possible. I think that as designers, we don't know what we don't know. I'm not a contractor. I've never built a bridge in my life. I've been in the office most of my career, never really been in the field. So I think having that feedback from those people that are actually doing those things is going to be what's very important to this process of trying to figure it out. These projects that PennDOT and Iowa have done are followed the stuff that the pooled funds put together. And I think that's very important to deliver these back to the vendors. And I think we're going to see from several vendors today what they can do with these models. And then we have to keep engaging with the authoring software vendors as well to try to figure out how can we get these solutions out of the product natively without having to go through the process that Grant did with a lot of post-processing with Blender and Bondi. So there's work to be done, but we're on the path. We're on the right direction. We've proven that you can deliver these, you can make deliverables from these projects, deliver out information in a digital way to give value and meaning to the field. So with that, I think I don't know if we're ahead of time or behind time, but that is what we had. Thanks.
All right, thanks, Thomas and Grant. And Grant, we have you scheduled for the next one also. So Grant's going to be talking about openBIM pilot project key takeaways. And when he finishes, we'll have the presenters come back to the front and we'll go through some Q&A.
All right, thank you. So yeah, I'll take the next few minutes to try to capture what you've heard, not only in the last two presentations, but really what you've probably heard over the last day or 2 days, depending on how long you've been here. Now, this is my perspective, my key takeaways. Joe, Alan, Thomas, you may have different takeaways, but I think we all can agree on most of these, and maybe we can discuss afterwards if you don't. So I apologize. I'm not a great producer of content for PowerPoints. I should have put this in AI, but I'm just going to throw it all out there. My 8 key takeaways. That last one, I just don't like odd numbers, so I needed an 8th. So it's 8. But I'll walk through each one and hopefully provide a little bit more information. The first one is IFC standards provide flexibility in model development. You've heard it over and over and over again, and you've seen this slide over and over and over again. But really, you know, it is important that, and it's refreshing as a designer, that we can exchange models easily, open up files, and really not have to deal with the issues of proprietary software. So the message is 3 pilot projects with ADCMS, 3 different workflows. The one you didn't hear about was using Quadri. That was the JMT project. They did some unique things with going from OBM and Pro Structures through Quadri into a clean IFC file. So again, really refreshing to see that on the front end as well as on the downstream end with construction platforms as well. Next is IFC standards provide new opportunities for technology providers. I think, and again, this is my opinion, it feels like open standards are opening the door in many ways to try to solve problems that maybe software vendors haven't had the time to address. So there's some opportunity for not only for the larger vendors, but smaller vendors to really get in there and try to solve these problems. So hopefully we see an acceleration of development as these open standards are produced. I think also there's a huge advantage to the users of software. I think Will Holmes, wherever he is, said it yesterday, that innovation or competition drives innovation. And this is something that we've seen even over the course of the pilots. We've seen a lot of new technology providers really hungry to get into this field and provide solutions for us. And so I think there's opportunities on both sides, the technology providers and the consumers of that technology. Next, we have software vendors need and want additional technical guidance. This is clear to us. Let me go to the next slide. Through this process, there's a lot of technical questions that still arise as we work through this. And this is not to say that this is not ready for implementation, but what I'm trying to get at is we need to provide clarification where clarification is needed to ensure that we have consistent implementation across the different software platforms. One example of what I would consider good documentation is what Rick has developed, and shout out to Rick Bryce from Washington State DOT. He's created a implementation guide on his own, and it's really detailed and gets into alignment and some of the alignment data. So if you have not seen this, I encourage you to get into it. It's really almost above my head in many of these chapters, but hopefully it can help with the consistency part of implementation. So again, thank you, Rick, for your time and putting this together. Next, pilot projects encourage software implementation. Implementation can be challenging. I'm not a software vendor. I don't claim to be an expert in IFC, although I'm starting to find my way around. Especially for the more established software vendors, it's challenging. They've established these workflows that we've asked them to provide solutions for many years, and now we're asking them to fit in open data standards. So we need to be somewhat patient while still trying to push implementation of open data standards. So we recognize that. I want to make that clear. Pilot projects provide real sample data sets for them to target. I think this will help them move in a direction quicker. If we can say and be clear about the final product of what we want and let them do what they do and find a solution on how to get from point A to point B. They help identify unforeseen challenges as well. We're not working through idealized solutions. Going through pilot projects will help us identify those challenges. And lastly, it shows commitment. Pilot projects actually having something tangible that DOTs are putting out there is really important. Like I said, it's a big investment, I'm sure, for software vendors, and to actually show that we're doing stuff rather than speaking to it and putting on slideshows is, I got to imagine, encouraging for them. Pilot projects elevate technical expertise, and this one's probably one of the more important for myself personally, but it gives opportunities not only for bridge engineers, but any design engineers or any non-technical folks to really elevate the understanding of IFC and collaborate better with technical experts. I think this was a gap that we recognized, speaking to the pooled fund in phase 1 of the BIM for Bridges side, is we had our technical experts and our engineers, and it's just really hard to communicate when you don't have a high level understanding of what the others do. So this was, again, big for me, and I think this is really going to show itself in the phase 2 updates that we're doing to some of these deliverables. It also results in improved data organization and presentation, higher quality reviews. Spreadsheets, Julie showed spreadsheets that were produced and she got excited, and I'm excited about those spreadsheets. I know this isn't probably the venue that people get excited about spreadsheets for, but for us, it's something that we're used to and we can see and we can review, and hopefully as DOTs and agencies, it's something that you can make sense of and provide valuable feedback to us. And we can have better, more informed conversations with software developers as our understanding of IFC is elevated. We're almost done, I promise. Pilot projects enhance industry engagement. Hopefully this one's obvious. You've heard pilot projects for the last 2 or 3 days now. Real world examples are better than theoretical examples. Theoretical examples focus on idealized solutions. Especially if it's a software vendor, they're not going to identify some of these challenges that we identify in our pilot projects. And I understand why, but we need to have actual projects that produce real problems and find solutions to those. Second to last, and this is an obvious one, I think, based on our past conversations, further enhancements to the TPF deliverables are required and are currently underway. And like I said, hopefully what we've learned in terms of elevating our expertise will result in much better, cleaner, useful deliverables from these pilot projects, not only BIM for bridges, but also BIM for infrastructure. I'm not going to let you read all that. I already talked about it. Lastly, like I said, this is my even number. We need more pilot projects. I was trying to think of an analogy because obviously we love analogies. I don't think we want to be the Polaroid of the past. I know this group really wouldn't classify themselves as that. I think we want to strive more for the SpaceX. I'm a big SpaceX fan, but if you can just look at, the duration of which the pooled funds have run and where SpaceX has come, and maybe not so much, a little less explosion and a little more quality product every time. I understand that it's a different environment and that we need to produce quality, and that's a requirement. I'm an EOR. I wouldn't want to make any sort of I wouldn't want to step back from producing that quality product. But basically, running through examples, pilot projects, whether it's MALD, whether it's for information only, even if it's a fake project, something that's been done in the past, it will all help and it will all result in very similar key takeaways to what you're seeing here. So that wraps up my key takeaways. So I appreciate the time and Q&A time, John.